Hi and welcome to this video where I'm going to introduce you to the concept of the factors that affect solubility. So in the previous videos I've talked about what solubility is and the solubility product, Ks, which is the equilibrium constant for solubility reactions. In this video we're going to talk in a general way about what some of the things that can affect solubility are and how that works. And then in subsequent videos, I'll be going through the specific details of different things that can affect solubility. So, first thing to think about is this really, we're still talking about an equilibrium reaction. So we've got to come back to Le Chatelier's principle. Le Chatelier's principle is that when a system is at equilibrium, and something disturbs that equilibrium, the system will act to restore the equilibrium. So it will act to reverse that change, whatever that change happens to be. So if we remove something from an equilibrium system, then the system will try and restore it. If we add something into an equilibrium system, the system will try and use it up to remove it. Okay, so we're always trying to reverse the process. So whatever we've done, we try and reverse. So if we think about this in terms of solubility, this is really where we're going to with this part of the topic. And a lot of it is logic. Now, there are lots and lots and lots of kind of rules that you can learn, but if you keep coming back to Le Chatelier's principle and thinking, what is actually happening in my system, then that will help you answer any question that comes up. Okay, so just to go back over again, Ks is a constant. It does not change unless you change the temperature, but we're always talking about standard conditions here. So 25 degrees C, 1 atmosphere of pressure, 1 mole per litre, not 1 mole per litre, 1 litre solutions. Okay, so Ks is a constant and it is the product, the multiplication product of the dissolved ion concentrations. Okay, now if we've got a pure system, so we've only got our sparingly soluble salt, then actually we're going to have the dissolved ions present in the ratio that they sit in the formula. But not every system is a pure solution. So if we've got other things present, then we have to think about how that works. So those Ks equals S squared and Ks equals the cubed root of 4S, and Ks equals 4S cubed, those only work as shortcuts in a pure system. As soon as we start changing the system through outside influences, then those rules that we've talked about in previous videos don't hold, and Le Chatelier's principle gets involved instead. Okay. So to change solubility, there are several things we can do, but they all come down to changing the concentration of one or other of the dissolved ions. Okay, so we could add a solution that contains one of those dissolved ions. That's going to have the effect of increasing the concentration of one of those dissolved ions. We could change the pH of the solution. Now that won't work on every sparingly soluble salt, but anything that includes, say, a carbonate or a hydroxide or anything like that, which are generally reasonably insoluble salts or ions, that's going to change the solubility. Or we could take one of those dissolved ions and we could react it with something else, which would have the effect of removing it from the equilibrium system. So all of these processes that we can do will have the effect of changing the concentration of one of the ions in that equilibrium system. Okay, so this is where Le Chatelier's principle really comes into play. So I'm just going to very briefly give you a consideration of this. So imagine we've got our equation, okay, where our sparingly soluble salt is breaking up into its ions. Now, it doesn't really matter whether it's a 1-to-1 or a 1-to-2 or a 2-to-1 or anything like that. Okay, I'm just doing this for simplicity's sake. So we've got our sparingly soluble salt. So we've got the undissolved solid and we've got the dissolved ions present. If we add one of the ions that is already present, so if we add some more, A+, or we add some more B-, then that is going to favour the reverse reaction, which is going to have the overall result of reducing the solubility, because we're going to take some of the ions out of solution and make more solid. So no matter what we do, if we're adding something into the product side, it is going to force that reaction to the left, which is going to reduce the solubility of that ion. Similarly, if we do something that removes one of the dissolved ions, so we take away some A+, or we take away some B-, in some way, shape or form, usually by reacting it with something else, then that's going to favour the forward reaction, which is going to cause more of that salt to dissolve. And if you've done 2.2, which is the standard that involves ions, then you will have played around with this, perhaps through making a complex ion or changing the pH that can force that sparingly soluble salt to dissolve further. Okay, so that's the general outline of how this all works. Please watch the next couple of videos where I'm going to go through this in considerably more detail. I'll see you there.